Have you ever stopped to think about why sending money online needs a bank stuck in the middle? I mean, why can't we just send digital value to each other? The same way we hand someone a $20 bill. Well, way back in 2008, a mysterious person or group named Satoshi Nakamoto dropped an idea on the world that could change all of that. So let's dive in and see how this thing actually works. Seriously, think about it for a second. Every single time you buy a coffee with your phone, pay a friend back with an app, or do anything online with money, there's always a trusted third party. A bank, a credit card company, some financial institution. They're always there processing the transaction. But why? Why can't it just be between you and the person you're paying? And when you put them side by side like this, the difference is just stark. With physical cash, it's direct. It's final. But our entire digital economy, it's built on these intermediaries. And as Satoshi's original paper pointed out, this whole trust-based model has some pretty big weaknesses. Transactions can be reversed, which means we need even more trust, which leads to higher costs and, of course, a constant risk of fraud. So to fix this problem, an incredibly elegant new system was proposed. One that could build trust not through some big institution, but through some really clever cryptography and pure mathematics. And that system is the blockchain. This right here, this is basically the mission statement, straight from the source. The goal wasn't just to create some new kind of money. No. The real goal was to create a totally new way for us to interact and send value directly to each other without ever having to ask a middleman for permission. It's all about replacing institutional trust with verifiable mathematical proof.
Okay, I know. That definition sounds super complicated, so let's just boil it down. Imagine a shared digital notebook. But this notebook is duplicated and spread across thousands of computers all over the world. Every time a transaction happens, a new line is written in the notebook. But here's the magic part. Once something is written down, it can't be erased or changed, ever. That's really the heart of it, a shared, permanent, unerasable record.
And, this idea didn't just appear out of thin air. It was really an evolution of ideas. Way back in 1991, researchers were already figuring out how to securely timestamp digital documents. Satoshi just brilliantly adopted that concept in 2008 for Bitcoin. But then, in 2015, Ethereum took this whole thing a giant leap further by introducing smart contracts, which basically turned the blockchain from a simple ledger into a global, programmable computer. All right, so how does this digital notebook actually get built? I mean, how do these individual records, these blocks, form that unbreakable chain we keep talking about? Well, it's all about how they're connected. It's actually a pretty logical process when you break it down. First, a whole bunch of new transactions get gathered together. Second, they're recorded onto a new block, just like turning to a fresh page in that notebook. Third, that new page gets sealed with a unique digital fingerprint called a hash. And fourth, and this is the really clever part, that new fingerprint is mathematically tied to the fingerprint of the block that came right before it. And boom, you have a secure chain. And this is why it's so incredibly secure. See, if you tried to go back and change anything in an old block, even a single comma, its digital fingerprint, its hash, would change completely. And since the next block is linked to that original hash, that link would instantly break, and then the next one would break, and so on, all the way down the line. To change the past, you'd have to rewrite the entire future, which is pretty much impossible. Okay, but hold on a second. If there's no central bank or authority in charge, who's making sure everything is legit? Who stops someone from just spending the same digital money twice? This is where the whole decentralized network idea comes into play. Right? This is the real power of decentralization. There isn't just one master copy of the notebook locked away in a bank's server room. Instead, there are thousands of copies held by participants or nodes all over the planet. So to cheat the system, you wouldn't just have to fool one central server, you'd have to somehow fool thousands of independent computers all at the exact same time. Good luck with that. So how do all these computers agree on what's true? They use something called a consensus mechanism. Just think of it like the rule book for a digital democracy. Before any new block of transactions can be added to the chain, a majority of the network has to vote and agree that, yep, everything looks good. This agreement is what keeps the entire system honest and secure. Now, the two most famous ways to do this are proof of work and proof of stake. Bitcoin uses proof of work, which is kind of like a massive computational race. Miners use tons of computing power to solve a complex puzzle, and the first one to solve it gets to add the next block. Think of it as one CPU, one vote. Ethereum, on the other hand, now uses proof of stake. Here,
Validators lock up their own money as collateral. They have skin in the game to get the chance to validate transactions. It achieves the same level of security, just with a tiny fraction of the energy. So here's the thing that is absolutely crucial to understand. This technology, it isn't just about creating new kinds of money. That was just the first proof of concept. The real revolution is in using this trust machine to completely reshape all kinds of other industries. And just look at these real-world examples. This isn't science fiction. Walmart is already using it to track food from the farm to the shelf, cutting down food recall times from weeks to mere seconds. In gaming, it lets players truly own their in-game items. Financial giants like BlackRock are putting real-world assets on-chain for faster settlement, and entire countries, like Estonia, are using it to secure sensitive health records. This is happening right now. And just in case you think this is some small niche thing, look at gaming alone. In 2024, there were 7.4 million daily active digital wallets in that space. That's millions of people using this technology every single day. That is real, tangible adoption on a massive scale. So why? Why are all these different industries jumping in? Well, it really boils down to four huge benefits. You've got advanced security, because that shared ledger is just incredibly hard to mess with. You've got increased transparency, since anyone can audit the history of a transaction. There's greater efficiency, because you're cutting out those expensive middlemen. And finally, improved traceability, letting us track pretty much anything with absolute certainty. And that really brings us to the most important takeaway of all. This is so much more than just a new kind of database or some fancy code. At its very heart, blockchain represents a fundamental shift. It's a new tool for building trust in a digital world, but it does it without needing a central gatekeeper. It just trusts the math. So that leaves us with a pretty fascinating question to think about. We've been handed this powerful new tool for establishing trust between people, between companies, even between machines, anywhere on the planet. The first chapter was digital money. The next chapters are already being written in supply chains, gaming, and finance. The only real question is, what are we going to build with it next?